Good evening, everyone, and welcome to the third edition of our Meet the Engineer series of events. My name is Dr. Toby Elushakin, and I'll be your host for this evening. Joining me today as my co-host is Delani Selvanathan. This event is an opportunity for young students, school leavers, and degree holders to understand more about engineering, both in terms of the work itself and in terms of personal experiences. Before we begin though, there are a few house rules that we'll need to quickly run through. Firstly, this event is being recorded, so those who are unable to attend this event live and those who are looking to access it and revisit it later on can get it. There'll be a link to the CPD certificates for this event, and that will be posted in the chat for everyone. Please use the Q&A function to prepare your questions for the speakers. My co-host will be collating those questions and putting them forward to the speakers. The webinar should take between 45 minutes to 1 hour, and we expect to and will try to keep to time. Our speakers are two amazing young professionals, Sabato Citro and Lindsay Stevenson. They'll be speaking to us about their journey so far and their experiences as engineers. Sabato will be going first, followed by a Q&A session, and then we'll have Lindsay speak with us, followed by another Q&A session. Afterwards, we have a few exciting and important announcements, and then we'll close the event. Without further ado, I would like to introduce our first speaker for you today, Sabato Citro. Sabato, stage is yours.
Hi, everyone. Good evening, and thank you very much for joining. My name is Sabato Citro, or you can call me Sab, and I have a presentation here for you tonight. So I'm going to share my screen now. Yeah, so as I said, my name is Sabato Citro, or you can call me Sab, and tonight I'm going to talk a little bit about my background, and I'm going to show you a timeline of my education and my career, and then I will share with you the experience that I've done during my master's thesis. So I've done an internship, and then I will also share my first work experience, so very close after my graduation, so the first job I had in my life, and as a final slide, then a little bit of what I'm doing now. So as a by background, I'm an electronic engineer, and I achieved this with a bachelor degree and a master's degree at the University of Naples in 2012. So this is in Italy, during my master's thesis, I decided to apply for Erasmus placement. So I did an internship in the Netherlands at UU Delft, where I also did my thesis. So this is the first example that I'm going to talk to you about a little bit later. So in the next slides. And after my graduation, so in 2013, I decided to join university again because I wanted to get specialized in something that I really loved. And in fact, I joined the railway system engineering, still in Italy at the University of Rome. And this is because my dad was a train driver and I always loved trains and operation and how they worked. So thanks to this course, in 2014, I had my first job at Trenitalia, which is the Italian main train operator, which is also the company where my dad worked. So I was very happy. And the first role I had was high-speed rolling stock engineer. And I'm going to talk to you about this role a little bit later in my third slide. And then in 2017, I moved to UK, still with Trenitalia. So I moved to the English office of Trenitalia, and I covered different roles, project engineer, and my current role, which is fleet improvement manager. And I have a slide on this as well. So let's crack on. So as I said, I did during my master degree, I did my thesis abroad, especially at Delft University. So I did this thanks to the Erasmus placement, which is a project that every student can apply. So it's basically to join a different university. And in my case, I also combine it with an internship at Dutch Meteorology Institute, which is basically a company that has the best tools or the best instruments in the country in regards to accuracy. And in fact, this picture here is one of the tools that I had in their lab, and the instrument that I used in my daily life or during my whole experience. So this is an instrument which is called vector nectar analyzer, and is used to characterize device at different frequency, like antenna or any other integrated circuit which works with radio frequency or microwaves frequency. So as you can see here for this graph, this device is connected to this vector analyzer is connected to the device under test, so it does measurements. And the goal of my thesis was to improve these measurements. So as I said, I would spend part of my day at the lab doing these measurements, but I would also use some software, which we can see here in this picture. This software is called HSFF, and basically this does a software where I could build a structure, which is this pink, for example, this pink structure that it's here, and it does simulation with an electromagnetic wave going through the structure. And as you can see here, this is a simulation of what happens inside the connector. So because there is this discontinuity, the electromagnetic wave lose energy, and this brings the measurement to be worse. So I use this software to create a model, to understand, to characterize a little bit what this problem, or the intensity, or the how big would be this problem. And a third software that I used, it's called ATS. It's a little bit maybe specific for the field where I work, but it's very similar to MATLAB, and it's just basically a software that I use to compute the measurement, to write equation, and to elaborate the measurements. So after I did my thesis, as I said, I decided to change my background, still as an engineer, but more specialized in railway. So I joined university, and thanks to university, I had a different role, which was the high-speed rolling stock engineer. And I've worked with the introduction of 50 new trains, 50 high-speed trains, and I work in a team that prepared the train for the passenger service. For example, here, obviously, we have a picture of the train, and obviously also a picture of the cab. So my daily job would be to stay on the train 24/7 and do different activities that I listed here, just to show you what they expect from me. That obviously I was a new graduate at the time, so I had to lead the Wi-Fi onboard installation, which allows obviously passengers to get connected with their computer or with their phone. So what I had to do, I had to lead the installation of all the components involved in the system that you can see here, for example, basically routers and cables. And obviously it's a little bit more complicated of a normal network, because a train is full of components. So what I were expecting to be was to read documents and understand what were the components and how they were connected together. And I had to lead technicians and people and finalize, obviously, the installation. So a lot of coordination, but also a lot of looking at documents and understanding the functionality of the system. Also, other tasks that I had to do in my daily job was manage maintenance activities. Obviously, we had to test this train, so this train will go out every night and do dynamic tests at different speeds, low, medium, and high speed, which were around 400 kilometers per hour. And obviously things could go wrong during tests. So what I had to do is repair the train when it would come back in the morning. And I have here a picture where we replace one of the main components of the train, which is called bogie, which is a mechanical component, and it supports the weight of the train and the weight of the passenger. So it's involved in the comfort of the journey. And obviously, even in this occasion, I had to coordinate activities and make sure that people and resources were at the right place at the right time. Also, I had to check functionalities and do tests on the train. So check functionalities. We had this new toy, and me as an engineer, I was expected to go on the train and check if all the systems on the train were working, like the controls, screens, interiors, and for example, also the Wi-Fi on board. And I have here a picture, for example, when we did the tests. Obviously, so you can see here there are a lot of antennas. So we were testing the electromagnetic field emitted by the train. And that's because the train has motors which make the train move. And when there is an acceleration or when there is a brake, these motors, they create a magnetic field. So with these instruments and this computer here, we were making sure that these magnetic fields stayed inside the train and wouldn't get out and hurt people. And then we also had to prepare the train for dynamic test run. So each test had a specific task. So a train had to come out in different configuration. And I have a picture here from the top of the train. So you can see these black tapes. This was for aerodynamic tests. So we were making sure that the components of the train were not affected by pressure that was too big and that would maybe damage the components. I also had to analyze the performance of systems. So this train had a very complex diagnostic system, so it would send out messages. So I had to basically use my computer and look at all faults and understand if something was wrong. And also I was obviously one of the first people to step on this train beside of my company. So I had also to share information with the next people, which were drivers or guards. So I had to share information on the functionality. So I basically had to read the structure, understand how things or how part of the train would work, and then share this information. And also being on the train 24/7, we also knew when things were going wrong. So we would also work to develop the prototype and to make sure that next generation would work better. And here, for example, I have a picture of the interior of the train. So this is the first train, so the first prototype. As you can see inside, is empty. So it's only the outside case. That's because when you do the first tests, you don't need to test the passenger comfort, for example. You only need to test the dynamic. So you don't need interiors. And as you can see here, this is a sort of lab with computers and all other devices that need to monitor the dynamic of the train. So how it would run, if there were any vibration, if brakes would happen in time, if the acceleration was expected as good as expected, or even, for example, we had to test. We have to run the train in poor condition, so in rain, and sometimes even spraying soap on the rail to test the train in poor adhesion condition. And then we end up with more recent roles, so project engineer and fleet improvement manager. So as an engineer, I work with a lot of projects, which makes it very dynamic, a very dynamic role. So what you are expected most of the time is to introduce new technology or to improve old technologies. And that means that you have to introduce a piece of kit, or you have to analyze what you have, the asset that you have, and make sure that you modify something to make it run better, or in a more efficient way, or in a cheaper way, or in a more environmental friendly way. And so the best way to describe what I do daily is to talk about the project that an engineer, in this case myself, is working on. And one of the projects that I'm working, obviously still related to trains, is called unattended monitoring system. So it's basically a piece of kit that I have to introduce that does measurement of an object, and it does it remotely, so without a person checking the object. And as you can see here, I put together a little drawing, so you can imagine this as a train. And what I had to do is introduce two pieces of kit, which is this black circle here and this box on a roof on the train, to monitor a component that is called pantograph, which is a component involved in the high voltage, in the power of the train. So I put some pictures here. As I said, this is one of the components that I introduced. It's an accelerometer, so it will measure some vibration happening on this component, which is called pantograph. And the other object involved in the system is this unit here, which talks through the Bluetooth with the previous object that I show you. And then it sends out alert or email or SMS when something goes wrong. So when that accelerometer detects a vibration or which means an impact, it sends out information to people that can then act and avoid any further problem. So let's have a look at the list of things that I have to do. So as I said, you have to introduce a new system. So you have to design it. So you have to think about what you want to build, and you have to build it in your mind. And then you have to buy the component, because you might need different units or bolts or different materials to put it all together. Then you have to assess the safety. So you are adding a new component, and you have to make sure that it's still safe to use. So in this case, we added a box on the roof. So I had to check that this piece is not coming out of the train and is not an hazard for people. So you have to do some calculation to make sure that it stays connected, or it stays bolted where it is. And then other activity are I had to produce drawing, I had to produce installation documents, I had to lead the installation, so I had a team of technicians. I had to explain what to do, and also make sure that they do the installation in safety. And then obviously, once the system is in place, you have to validate the final product, which in this case, as I said, is an alert or an email or an SMS with an information of what happened and where it happened. So once the system is in place, you have to check that it does what it was supposed to do. I think that was all. So I hope you guys enjoyed it. And
All right. Thank you very much, Sabato.
okay.
You can stop the screen. Yeah, thank you very, very much for that presentation. It was quite a lovely experience to go through your career from when you were a student up until now, and seeing all the different transitions in your career, essentially. So that was quite fascinating to go through. Thank you very much for that. I would like to just say now that if people have got questions for Sabato, please put them in the Q&A box, and we'll be able to get them to Sabato to be able to answer. So Sabato, you mentioned that you had to transition from your work in Trenitalia in Italy to the UK arm. And I imagine that we have some people in the audience, some people within the IET network that have moved from one country to the other, or have moved from a different country, either in the EU or from Africa or Asia or wherever, to the UK. And I just wanted to get your take on your experience moving from Italy to here, how you were able to transition, if you faced any kind of challenges, and how you were able to overcome them.
So yeah, my transition was very smooth. First of all, because obviously my company provided me everything, logistically speaking, and also I knew already what I was coming because I had to do the interview. And also the second reason why it was really smooth is because this was already my second experience abroad. So when I talk about the first experience, instead one where I worked in the Netherlands, that was a shock. That was much harder. First of all, because I only had a small scholarship. I told you that I did an Erasmus placement, so I had a very, very small scholarship from the university. So logistically, at the beginning, I was a bit of a struggle because obviously I couldn't have a hotel, I just had a small room, and also it was my first year abroad, my first time abroad, far from family, and also my English skills were not the best. But thanks to that experience, when I moved here in England, it was very smooth. I didn't miss home, and I had really a good English level, and so it was great. And talking about that experience in the Netherlands, this is an advice that I want to give to the audience. As I said, it was a bit of a struggle at the beginning because my scholarship was really, really small. So I had to rely on money from my family. You know, many students wouldn't have done it. So in fact, many of my colleagues at university, they refused because it was not sustainable. I'm not sure if I was smart, I'm not sure if I was stupid at the time, but I did it. And as I also said during the presentation, I had the opportunity to do an internship, and then internship was paid. So at the end, also, you know, the economic side of the project was sorted. One of the advices, this kind of experience, they help you after the graduation, but even at the end or during your career. So you just have to jump in, and yeah.
All right. Thank you very much for that. Thank you. I agree that, regardless of anything, you just have to try and jump in. And yeah, I actually applaud your guts for taking on that opportunity, even though the money and things associated with it didn't seem very very encouraging at the time. But it seems like it's paid off. So
yeah, and even now after 7 years, if I do an internal interview with my HR, so internal HR, they still ask the same question. Oh, I can see that you did an experience abroad. That's very interesting, and so it worked.
Yeah, all right. That's good. We've got a few other questions from the audience that we'd like to quickly ask. If you could give a few quick answers to some of these questions. So the first of them is, moving across to the UK, have you faced any challenges regarding EU standards and something called TSIs, which may not necessarily apply here? So moving across from Italy to here, looking at standards, have you faced any kind of issues?
Yes. So in my recent project, I had to do the engineering change for this new system. So I had to apply the regulation, or the English regulation that apply to a rolling stock. So I had to start from scratch. Obviously, new trains, they have European regulations, so they should be the same. But apparently, UK is going for a different route now that left Europe. So yeah, I would say I had to start from scratch. I had to read again the standards, the English, because the numbers, the code, they are classified with numbers. Never heard of those. Yeah, so
All right.
yeah.
All right. Thank you. For the person that asked that in the audience, and for those who are interested in that in the audience, yeah, there does seem to be a bit of a difference, and one has to seem to study again for different standards in the UK. So next question is, what encouraged you to get into engineering in the first place? If you could give a quick answer to that.
So I really loved electric. So as I said, my dad was a train driver, and he was very good at. He was an electrician as well, so he knew how a train worked electrically, and he was explaining me what was a train before, when only electric components were available, and what was a train after, when electronic component came into the market or were invented. So that was the reason why I went to electronic engineering, and afterwards also specifically for railway engineering.
All
railway
right.
engineering, yes.
All right, no problem. Thank you. Our next question is, have you had to work with a team of people with a range of skills and backgrounds, and how did you find that?
So yeah, talking about my first experience in the Netherlands, obviously the Netherlands has the Netherlands has quite more of different backgrounds, and so I work with different people with a different range of skills, especially because, as I said, I was in between the TU Delft, which was the university, but also with this company where I did the internship. So I had to deal with 2 different offices, which logistically also wasn't that easy, because I had to cycle from one building to another. I think it's you just have to practice and make sure that culture is not a barrier when you liaise with different people. So obviously, when you start, that doesn't come easily, but then when you practice, it's not a barrier anymore, and it becomes easier. So practice is the answer.
All
so
right.
Thanks, Paul.
Yeah. Oh, we've got one more quick question. If you could just answer this very quickly. It says, do you feel you're able to transfer your skills gained in rail to other industries?
So the good thing of working on a train operator and in railways is that, especially on the train, so if you look at that train that I showed you in the presentation, so that train has millions of systems. So your job is quite dynamic, and you can work for different systems. So you can work, for example, with the Wi-Fi, or you can work with the motor and have a bit of an understanding of how magnetic fields work in a motor, or you can maybe work with toilets, which is a completely different system, which use pressure and water. Or you can also understand a little bit of how mechanical components work, so springs and material. So yes, I would answer that I could transfer my skills because they are so different. Yeah,
all right.
Definitely.
All right, thank you very much. All the other questions we'll try to answer after our second speaker has spoken. So thank you so much, everyone, for your questions. And thank you especially to you, Sabato, for your presentation and for answering our questions. Our next speaker is Lindsay Stevenson. Lindsay, you could turn on your video now, if that's all right, so our audience can see you.
Oh, it's not letting me turn my video on because it says the host has stopped it.
That is. Can you try that again?
Does that work?
All right, there you are.
Thank you.
Lindsay,
hi everyone. Thank you.
Yeah.
Hi everyone. I'm Lindsay Stevenson and I'm a hydrogen innovation engineer at National Grid. And today I'm just going to talk to you a little bit about my career so far and what I do. So I'm going to go through why I chose engineering as a career, hopefully brief overview of what I've done so far. And I'm going to talk a little bit about the energy transition because it's really important for the role that I've just started. And also I think it makes it a really exciting time to be an engineer. And I'm going to talk about one of the problems that I'm looking to solve in my new role, which is compression of hydrogen. And I'll just go through a typical working day. I'd say no day is the same as another one, but just give a sort of a simple rundown of some of the tasks that I do day to day. So at school, I loved maths and science, and I always thought I would end up in some form of STEM career. But it wasn't until I attended a programme called Girls Get Set, which was something that tried to encourage women into engineering and science. And I stayed at Heriot University for a week and got to do a lot of activities, which looked at lots of different types of engineering, including chemical, electrical, mechanical. And from that, I decided I did want to be an engineer. And so I went to Heriot University, where I got my master's in mechanical engineering. And during my time at university, I completed 2 summer placements at a power station. And they made me decide I wanted to work in more technically involved in detail. And so I decided I wanted to work at an energy consultancy, so a company that provides consultancy to people in the energy sector. So I started my career as a graduate at DNV in 2012, which at the time was GL Noble Denton. And I was really lucky because I got a really broad experience straight away. I done design, I looked at operational projects, carried out pipeline integrity assessments, and also created a lot of procedures and policies for the industry. And during that time, I also done a lot of work on climate protection systems and the design of those systems. And that meant I was able to go out to Israel and provide design assurance for the construction of a distribution pipeline, which was quite exciting because I got to do all the reviews of the design and then go over and see it getting built. And in 2017, I was promoted to senior engineer at DNV, and I also became a chartered engineer a month later. Then in the next sort of year, again, I carried on doing a lot of different projects, but I guess the biggest project I worked on at that time was going out to Japan and doing a pipeline integrity management system audit. So that included looking at the full pipeline system, everything that it incorporated, and making sure that the management system in place, that was maintained properly, that had been operated the way that it should be, and to give a presentation at the end of the week that I was there saying what needs to be improved and what solutions I would have to the problems. A person that loves to learn. I want to always be learning my whole career, so engineering is pretty ideal for me. And so I moved down to Newcastle from Edinburgh and became a senior engineer at Rosen. So in a lot of the same sort of projects that I'd done in my previous role, working on gas industry pipelines and assets, but I also started to work more in innovation. So a lot of the innovation projects that I worked on whilst I were there were looking at new pipeline repair systems that could be used on distribution systems. So we do have a lot of repair systems that are used on metallic pipe in the gas industry, but not so many that can be used on polyethylene pipe, which is used for the lower pressures. So I've done a lot of work in my time at Rosen, trying to look for new repair techniques and seeing whether they could be used on the system. Again, towards the end, I was beginning to, I guess, a lot. And in the past 2 years in the gas industry, there's been a big focus on hydrogen and the potential to use that as an alternative to natural gas. So this year I decided to apply for a role at National Grid as a hydrogen innovation engineer, and I started that role at the end of September. So just to go over quickly the energy transition, there's obviously a target in the UK for us to achieve net zero by 2050. And to meet future energy demands, we need to make sure we're using as many different green energy sources that we can. And we also want to try and repurpose existing assets where we can, as that makes the transition more cost effective for the end user and for people in their houses that are going to be using energy. So hydrogen has been seen as a possible alternative because we could use the pipelines that are already installed in the UK to transport hydrogen. And so my new role is the technical lead for a theme within National Grid. The theme is a bit of a mouthful. It's asset development for risk mitigation. So I'll be looking after all the projects that fall under developing the current assets for use with hydrogen. So I need to understand what assets we can keep the way they are so they can transport hydrogen, ones where we may need to modify them, and others that need to be replaced by something completely different to allow the transition to happen. And also for the transition, the most important thing is that we carry it out safely. So I'll be in charge of a lot of the safety and risk analysis projects as well. So for example, when you have a site, you'll have hazardous area zones at each site because of having a flammable gas. And if we change from natural gas to hydrogen, those zones will get larger. And that determines where you can put electrical equipment on site, what type of electrical equipment you can use. So with that, we need to make sure that we're updating the standards, policies and procedures as we're doing the energy transition, because this is completely new to everyone. We obviously know how to operate a natural gas system, but we don't know how to do that with hydrogen yet. And we need to make sure that in the future, all those pipelines and assets can be operated safely whilst they're transporting hydrogen. So I've not been in my role very long, so I haven't really started any big projects yet, but what I have started doing is scoping out projects that I want to work on in my theme and what the problems are that we need to solve. So engineering, to me, if you're an engineer, you're a problem solver. That's what you're trying to do. So at this moment in time, we need compression. It forces the gas through pipelines so that it can be transported to wherever the demand is. And in the UK, we've currently got 24 compressor stations, and there are 70 compressors in total. And most of these are centrifugal compressors, which basically is a high-speed impeller, which creates kinetic energy. And then this goes through a diffuser, where that energy is then converted to static pressure. And that's how they get the pressure increase at the outlet of the compressor, which means the gas is boosted so it can keep on traveling through the pipeline. So ideally we want to repurpose existing assets. So the project I'm looking at the moment is whether we can use the current compressors that we have on the system, but to transport hydrogen. So the sort of challenges we have with that is that from research that's been carried out worldwide, we do know that more power is required to compress hydrogen than what is required to compress natural gas. It's likely that we'll need more compressing stages to achieve the same pressure ratio. So when you have, at this moment in time, we have maybe one compression sort of stage where we get the increase in pressure that we need. Because of the change to hydrogen, we'd maybe need 2 or 3 to achieve that same pressure at the outlet. In the future as well, there's likely there'll be a variability in what we're transporting. So by 2050, the aim is that we'll be transporting 100% hydrogen, but in the meantime, there's just not enough production in the UK. It's not mature enough for us to be able to do that. So it's likely that we'll start with a hydrogen natural gas blend. So about 20% hydrogen and the rest being natural gas, which will reduce emissions in the meantime before we have the hydrogen we need to be able to transport it. Now, with that changes the operational envelope of the current compressors, and they are quite rigid. So if you have different gas characteristics, it is going to change the efficiency of that compressor. So there is a challenge that we've got to overcome and figure out whether we can use the current compressors or whether we need another solution. But what we're going to be looking at is whether some modifications that we carry out will enable us to transport hydrogen. And some of those may be increasing the impeller speed or regearing and modifying the compressor wheel so that it can basically turn faster, creating more power and giving us that pressure boost we need as it's more difficult to compress hydrogen. So that's kind of one of the problems that I'm looking at just now, but I just wanted to go through a typical working day as well. Now, it's quite difficult to do this because I would say every day is different, but just sort of day-to-day tasks. First of all, I'm pretty lucky that I get to spend quite a lot of time on site and equally in the office. So it's a really good variety between sitting at my desk but being out at a station or something like that. And I also get to attend a lot of suppliers' premises where they show us how their innovation works, which is really cool. So, but I guess my responsibilities are researching projects worldwide. So if I've got an idea or a problem I want to solve, I've got to make sure that we're not duplicating research that's already been carried out. So we need to make sure that what the research we're doing is new and it's actually going to help the transition happen, and we're not just doing something that's already been done. And I need to identify potential solutions to those problems. And a lot of the time, I'll maybe Google's a good one if you want to try and find some companies. But also, there's quite a lot of podcasts around hydrogen and the energy transition. And actually, a lot of the companies I've heard of and contacted have been from podcasts or articles that I've read. And then I'll organise a meeting to go and speak with them. And they can tell me about their solution, and we can determine whether we think we want to take it further and whether it's feasible to use on the networks. I then got to do all the applications for funding, describe what the problem is, what our proposed solution is, and why it's needed for the energy transition. Because they're energy transition projects, they are funded by the government, and you need to make sure that you are going to have something at the end of it which can be used not just within your own company, but to help people and other companies in the UK and worldwide achieve net zero too. once an innovation project's up and running, I'm the project manager / technical lead for it. So kind of 2 different roles for the portfolio. And really, I want to make sure that we are getting the outputs on the project that we need at that point. So we are getting the answers that we want, so that then we can put a plan together for implementation. And again, that plan would initially be for within our company. But in the future, I want to have a plan in place so that other people, so other networks can implement the same solution. And also that it's easy for people internationally to replicate what we've done. I think one thing that gets missed a lot when people talk about energy transition is I think it's really important we all work together. There's quite a lot of competitiveness between different solutions, but really if we're going to achieve this, we need to work together internationally. Different companies need to work together so we can get there within the timescales that we've been given, because it is a massive challenge. So that is a very brief overview of my career and what I do. If happy to answer any questions.
Thank you so much, Lindsay. That was a fascinating run through of a really interesting career, I should say. Moving from DNB now to where you are as a hydrogen innovation lead, and hydrogen also being at the forefront, at the cutting edge of the net zero movement. It's quite fascinating, and I would imagine, your position is quite enviable. Thank you.
And I do love my job very, very much.
Yeah, thank you so much for that presentation again. We've got a few questions to run through. Honestly, we might not get through everything, just to let the audience know, but then the speakers will be able to answer them later on, and we'll be able to distribute the answers to everyone. All right, so we'll get through the questions very quickly. The first one being, what are the key safety challenges in transporting hydrogen through the grid network?
So there are quite a few. Sorry, excuse me. I guess key safety challenges, I guess just with it being something new, and we don't have the procedures that we have in place for natural gas at the moment, and because we're learning something new, there's always going to be a sort of a risk to safety, because you need to make sure you're doing everything thoroughly before you implement anything. Secondly, for the newer grades of pipeline that we have in the system, there is an increase in risk for cracking, which is quite funny because actually the older grades of material are unlikely to degrade quicker than the newer materials. So it's actually high grade steels that are more likely to have hydrogen-induced cracking. So one of the things that we want to work on, as well as doing lots of material testing before we transporting natural gas through a network is a risk as well. But we have inspection regimes and maintenance regimes in place that mitigate that risk. So that's what we're looking for hydrogen. But what we need to figure out with all the material testing is, do we need to increase that frequency, and what that frequency has to be of inspection, and then what repairs we can use on a hydrogen system. So it's really about, in the next few years, figuring out what the procedures are, because I think although there's an increased risk, it can always be managed by inspecting and maintaining the pipelines. I don't know if that answers.
Yeah, that makes sense. I do have a little bit of reliability and operational maintenance background, and just to follow up on that, does maintaining the equipment, does it require regular inspections, or do you monitor things remotely? Do you have sensors or things like that?
There are some things that are monitored remotely. There's actually a lot of inspection equipment on a pipeline. So you do first of all have a chloride protection system, which obviously protects the pipeline from corrosion, and a lot of those are remote monitoring remote monitoring situation where the value of polarization, I don't want to go too much into the technical detail of CP, but is fed to a main computer, so you can always see that your CP system is working correctly. But in terms of inspecting for defects, what happens is we run pipeline inspection gauges to the pipelines every few years, and what they do is they're really impressive pieces of equipment, which basically are put into the pipeline, and they go along with the flow of the gas, and they are actually able to find where there's a feature, and that could be corrosion, it could be a dent, it could be a crack. There's a lot of tools out there to find different things in pipelines, and we use that quite regularly, and they use that information as well over maybe 2 or 3 pig runs to see whether a defect is growing and whether a repair needs to be undertaken on that defect. And there's obviously acceptable limits for defects where you can leave it in situ or where you need to repair it straight away.
All right, thank you. Thanks very much for that. We've got time, I think, for 1 or 2 more questions. So the next question we have is, would it be more efficient to transport ammonia and convert to hydrogen prior to combustion? I have no idea what that means.
So that is something as well that is being looked at, and something that again is not being ruled out. We're very much at the start of looking at the different. There isn't a completely clean process. And at first, when we start producing hydrogen, we'll be using similar processes, but the aim will be by 2050 that we won't be using any process that has any form of emissions. It'll be mostly electrolysis or using carbon capture to capture any emissions. So ammonia is a good option, but I think there are more safety concerns associated with that. The way it interacts with some of the materials would be more detrimental than hydrogen. And yeah, it's something that I think if hydrogen was found to be completely inefficient, it would be looked at. But I think hydrogen's safer than ammonia, which is why that's the preference.
Okay. A lot of the other questions at the moment are a bit more technical, and I just wanted to ask something that isn't really technical for those who might benefit. You mentioned that you had 2 internships during your uni days, and just to ask, how did those contribute to your career later on, to getting a job and then to your progression?
Sorry, I lost that question a part of the way through. Can you?
That's all right. I was asking how your internships helped with getting a job afterwards as an engineer and then growing in your career, essentially.
Yeah, I think they were really beneficial because, first of all, they were much more hands-on than what I've worked in the consultancy, but because I'd worked in, I guess, a live plant environment, I had seen the equipment that I was then working as a consultant on, if you know what I mean. So I'd seen it all in real life. And I'd done a lot of risk assessments, method statements, for carrying out operations on live equipment or decommissioned equipment. So that came in really handy during my interviews because I could talk about that. And I think sometimes that more practical experience can be difficult to come by from graduates, is what I would say. Obviously, people who go for apprenticeships and they get that really good experience, but I think sometimes graduates don't. So that definitely helped because I got asked a lot of safety and PPE questions and things like that in my interview, which were no bother to answer.
All right, that's lovely. Thank you so much. We've got quite a number of other questions, a lot of them technical, but it's really nice to see the engagement. We will send these questions over to you, and if you could maybe provide a written answer, we can then send the answers to the audience. One last question for Sabato that someone asked in the first session. It's a bit of a tricky one. Someone asked, who has the best trains, UK or Italy?
Well, I think the answer is who has the newest trains. Yeah, but I think obviously I have to say Italy. but UK is going to have some new trains soon, so it's going to be at the top in the next 4 years, I think. And if I can answer to this question, most of the time a train is just built with a combination of components that come from all over Europe and sometimes all over the world. So an Italian train is never an Italian train, is a European train. And I suppose the same happens also in UK. So every component comes from a different country.
All right, that makes sense. Thank you both so much. We have a few announcements to make very quickly. I'll just quickly share my screen. Sorry about that. I wonder if everyone can see my screen. Apologies for that. Let's see. Okay. So we've got a few vacancies on the London Young Professional Network Committee. If you're interested in taking up a position of leadership within the committee and helping to really make an impact in the lives of young professionals, there are a few roles available on the committee for you to take up. The first of them being the role of the vice chair, and this role will help to lead the committee as well and act as a deputy and a successor to the chair. We have a role as an institution liaison, where you work with other professional engineering institutions to develop events, develop partnerships, and what have you. And we also have the role of the event manager for the Present Around the World conference as well. So this is quite important. And if you want to take up this role, please contact us. We also have the role of the secretary within the committee. In this role, you will help to administrate the London Young Professional Network Committee and be a crucial part of the committee as well. If you're interested in taking up any of these roles, please contact Chris Winder, that's our chair, at chris.winder@iitvolunteer.org. Now to our really exciting announcements. We've got two special events coming up before the end of the year. The first of them is our next Meet the Engineer event with the finalists of the IET Young Women Engineer of the Year Award. That is quite amazing. We've got 6 immensely talented and accomplished women who will be speaking about their experiences, their job roles. We'll get to ask them quite a number of questions and get a lot of wisdom from them, from their experience. We've got so much we can learn from them, and I definitely think that you will enjoy being a part of that. Fun fact, one of the finalists is actually a member of the London Young Professional Network Committee, so make sure you are there. Our next event on the 13th of December is our Christmas special. And for a Christmas special, we've got 3 very special speakers. This you have absolutely got to see. We've got Sir Julian Young, the current IET president. We've got Professor Danielle George, the immediate past IET president. And then we've got, if you know him, Mark Rober. He's an inventor, engineer, and YouTuber with more than 20 million subscribers. Yes, you heard that right. So we've got these 3 speakers in line to speak to us on the 13th of December this year for our Christmas special. Just imagine the amount of wisdom that these 3 would be able to dish out. So please make sure that you register for this event. We'll be providing the information on these events in the next few weeks. So please make sure you register and you are there. We've got 2 very special events before the end of the year. Please be there. Thank you all so much. On behalf of the IET London Young Professionals Network, we are extremely grateful to you for being part of this. To our speakers, Sabato and Lindsay, thank you so much for being a part of this. Make sure you contact us for more information on how you can join the team. To the audience, thank you all so much. Follow us on social media, on Twitter, LinkedIn, Instagram, and Facebook. And I think that's everything. Have a wonderful evening, everyone, and take care. Bye.